Today we will talk about the chemistry of plastic, types, properties, and environmental impact. Next, I would like to introduce our team member. First is me, Aina Mardia binti Muhammad Amin. For environmental impact, Noor Shanina. For reaction, Muhammad Nasruddin. For specific application, Muhammad Nur Hasrizal. For characteristic and how the product produced is Muhammad Lukman. Okay, I will talk about types and properties of plastic. We choose two applications is polyethylene PE and polyethylene terephthalate PET. PE is a high density polyethylene HDPE is of procure such as detergent bottle. Low density polyethylene LDPE is relatively transparent such as plastic bag. And also polyethylene density, strength, impact resistance, thermal properties, chemical resistance, and water absorption. Ultra high molecular weight polyethylene UHMWPE is the heavy hitter capable of resisting impact and absorption. For polyethylene therapy, PET is agnostic PET is non-crystalline and transparent. Crystalline PET CPET has a semi-crystalline structure. Recycled PET RPET made from recycled PET product reduce waste and conserve resources. PET properties include strength, flexibility, transparent, heat resistant, and resistant to chemical.
I'll continue with the environmental impact of plastic. Plastic pollution alters habitats and natural processes, thereby reducing ecosystems' ability to adapt to climate change, which directly affects millions of people's livelihoods, food production capabilities, and social well-being. Plastic is a major contributor to both land and water pollution. When it is not properly disposed of, it can end up in our oceans and rivers, thereby harming marine life. The production and incineration of plastics significantly affect air quality. Industries emit large amounts of carbon monoxide, dioxin, and hydrogen cyanide during these processes. These gases pollutants contaminate the air and cause respiratory diseases, nervous system disorders, and immune suppression in human beings.
Now I'm going to explain about reaction of recycling PET. This is several ways of how to recycle PET. Firstly, pyrolysis. Pyrolysis involves the thermal degradation of PET to break down the polymer into smaller molecules. It is a promising method for PET recycling, but the efficiency and yield can be vary based on the specific pyrolysis conditions and process parameters. Hydrolysis. Hydrolysis is a process that uses water to break down PET into its monomers. The efficiency and yield of hydrolysis can be influenced by factors such as temperature, pressure, and catalysts used during the process. Methanolysis. Methanolysis involves the reaction of PET with methanol to produce monomers like dimethyl terephthalate (DMT) and ethylene glycol. The yield and efficiency of methanolysis can be affected by the reaction conditions and the presence of impurities in the PET waste. Glycolysis. Glycolysis is a method that uses glycol to depolymerize PET into its constituent monomers. The efficiency and yields of glycolysis can depend on the glycol used, reaction conditions, and the purity of the PET feedstock. Ionic liquid and phase transfer catalyst. This method involves the use of specific catalysts to facilitate the depolymerization of PET. The efficiency and yield of these processes can be increased by the choice of catalyst and reaction condition. Finally, combination method. Combining different chemical recycling techniques such as glycolysis and methanolysis, glycolysis and hydrolysis, or methanolysis hydrolysis can offer improved efficiency and yields compared to individual processes.
Alright, so for this slide, I'm going to talk about specific application of polyethylene and polyethylene terephthalate. There's two specification of polyethylene, which is high density polyethylene HDPE and low density polyethylene LDPE. The common application of polyethylene is packaging, pipes and fittings, household, and agricultural. So for packaging, HDPE commonly used for making rigid containers such as bottles and other containers, plastic containers, while LDPE is utilized for flexible packaging solution, including plastic bags and films and other similar things. Alright, so moving on for the next one is pipes and fittings. Polyethylene is resistant to corrosion, make it ability to withstand high pressure, so it's suitable for water supply, gas distribution, and also networks and sewage pipelines such as water tanks. Alright, so for household, polyethylene is used for manufacturing for food, which is containers and others. Alright, so the last one is agricultural. Why polyethylene is used in agriculture? Because its adaptability and contribution to improve agricultural productivity, such as ropes, fishing. Next, talk about specific application of polyethylene terephthalate (PET). So PET, the specific application is divided by 4, which is packaging, textile industry, automotive industry, and also electrical and electronics industry. Alright, so for packaging, PET is used for making plastic bottles, such as mineral water and carbonated drinks. So PET also used for films, because it's ideal for use in tape application. And other than that, PET also can be thermoformed to make packaging trays and blisters. In food packaging, its chemical internals with other physical properties. And other packaging application of PET is including rigid cosmetic jars, microwavable containers, and transparent films. Alright, so moving on to textile industry. For textile industry, we have polyester fabrics, which are very strong and flexible, also lightweight, so it can reduce wind, drag resistant, and more resistant to tears. PET also used for screen printing, filter oil, and sand filtration. It's also used for bracing wires for agricultural application, such as greenhouse. Alright, so it's also used for woven, knitting belt, filter cloth, and other such industrial application. So for automotive industry, PET is used for making wiper arm and gear housing, headlamp retainer, engine cover, and connector housing. Alright, so for the last one, it's electrical and electronics. PET is very effective polymer to replace die-cast metals and thermoset.
Chemical resistant. Polyethylene resists to many chemicals including acid, bases, and also organic solvent. This makes it suitable for container and pipe that need to withstand hard substance. Other than that is also durability. Polyethylene is known for its toughness, durability. It has good impact resistance, which makes it suitable for the product that need withstand raw handling. Other than that is also low density. Polyethylene has relatively low density compared to other plastic, resulting in lightweight product. Lastly, polyethylene is also electrical insulation. It is an excellent electrical insulation, making it ideal for use in electrical wiring and cable. Okay, for the last slide, I will share how polyethylene were made or processed. So polyethylene were made by polymerization process. It has 3 steps, which is high pressure polymerization, low pressure polymerization, and also solution polymerization. For the high pressure polymerization, LDPE is produced using a high pressure, a free radical polymerization process, typically at pressure of 1000 until 3000 atmosphere and temperature at 150 until 300 degrees Celsius. For the low pressure polymerization occurs at low temperature and pressure using a catalyst system to produce a high density polyethylene HDPE with a linear molecular structure. For the last one it is solution polymerization process, which is polymerization occur in a solvent, allowing for a better control over molecule weight distribution, resulting specialized polyethylene grades.